Creating a perfect AI for a snake game involves several steps, from basic implementation to advanced techniques like reinforcement learning. Here's a breakdown of how you can approach creating an AI that plays Snake. First, you need to create the Snake game itself. You can do this with libraries like pgame if you're using Python or Unity if you're using C#. A basic snake game will involve a game grid, a snake controlled by the player or AI, and apples or food appearing at random locations. The snake grows longer when it eats food. The game ends when the snake collides with itself or the wall. In the early stages, you can create a basic AI using a heuristic approach. This involves defining simple rules that guide the snake's movement. The AI's goal is to eat food by always heading towards the nearest food, avoid obstacles by not hitting the walls or the snake's body, and use a simple distance-based approach where the snake moves toward the food by choosing directions that decrease the distance to the food. Here's how you could approach it. For each possible move, calculate the Manhattan distance from the snake's head to the food. Then, choose the direction with the shortest distance. Collision avoidance. Check if moving in a direction leads to hitting the walls or the snake's body. If so, avoid that move. Pathfinding algorithms, which are optional. You can implement algorithms like A* to avoid collisions and find the optimal path to the food. Advanced AI through reinforcement learning. To create a more intelligent snake AI, you can use reinforcement learning, often referred to as RL. In RL, the AI learns how to play snake by trial and error, adjusting its behavior based on rewards and punishments. State space. Define the state of the game, such as the position of the snake, the position of the food, and any obstacles. Actions. These are the possible actions the snake can take, like moving up, down, left, or right. Rewards. The AI receives a positive reward when it eats food and a negative reward when it collides with the wall or itself. Q-learning. This is a model-free reinforcement learning algorithm where the AI updates a table, called the Q table, based on the actions it took and the reward it received. Over time, the AI learns the optimal path to eat food while avoiding collisions. Deep Q-learning. For more complex environments, you can use a neural network to approximate the Q values instead of a simple Q table. This is especially useful if the game grid is large. Reinforcement learning workflow. First, initialize the Q table or neural network with random values. Then, the agent interacts with the game by taking actions, observing the next state, and receiving a reward. Next, update the Q table or neural network based on the reward and the next state. Finally, repeat the process and improve the AI's decision-making over time. Improving the snake AI. Once you have the basic or reinforcement learning-based AI working, you can focus on improving the AI's performance. Look ahead. Make the AI evaluate future moves, like moving several steps ahead, to predict and avoid potential dangers. Snake growth strategy. As the snake gets longer, the AI should modify its behavior to account for its increasing size and the reduced available space. Risk assessment. Add a system to determine how risky a move is. For example, a move that leads to a tight spot could be dangerous. Behavioral tuning. Fine-tune the exploration-exploitation trade-off in the reinforcement learning model. You want the AI to balance between trying new actions and exploiting the learned ones. Tools and frameworks. Pgame for implementing the basic game and testing the AI. OpenAI Gym. If you want to train your AI using reinforcement learning in a controlled environment, TensorFlow or PyTorch. For deep learning approaches if you're using deep Q learning.